lead to the photoelectric effect, and here the signal about 0 and 1, converting by the computer, and we can find out the information. Next, I want to introduce everyone in everyday life using one-dimensional barcode. The use of one-dimensional barcode that identify the goods and merchandise information already exists in the computer. Carefully observe the barcode of each commodity while buying a region in street techniques and number analysis. The figures were representative of the country code, manufacturer code, product code, and trade code. With barcode shifting above a red line, the intensity distribution of the refracted light measured in by the corresponding product information from the computer, which is one-dimensional barcode.
Hello everyone, I want to introduce two-dimensional barcode. Two-dimensional barcode can store more data than one-dimensional barcode. It has positional points and the fault tolerance mechanism. The function of the positional points is that the reader can read any direction. Unlike the one-dimensional barcode, only can be read in regular angle. The fault tolerance mechanism, when the barcode is stamped, it still can be read correctly, and the highest fault tolerance is 50%. There are many types of two-dimensional barcodes. The most commonly used in Taiwan is QR code. QR code can be read by smartphone. For example, the communication app Line can add new friends by mobile barcode. There are two-dimensional barcodes on package of the product. It's usually about the activity site and the information about the product.
Hello, I introduce RFID. RFID is radio frequency identification. The principle of operation is the use of a radio wave emitted from sensors. Touch the RFID text switch within the range. The current is generated by electromagnetic induction, and operating the wafer on the RFID tag, and information will be passed back to the computer. And the computer interpretation of data is true or not. Energy source to drive the difference. RFID tags divided into active and passive, two types. passive text without a battery device itself, thanks to the inductor current generated by electromagnetic induction, so that the sensor devices only issue a passive response to the signal sensor, while active text have a battery built in. You can take the initiative to transmit the signal for the sensor to read. The signal transmission range is relatively wide than passive.
Today, I want to introduce the kind of the RFID. When it comes to the way we classify the RFID, we use the frequency of the RFID. The frequency from low to high are low frequency and the high frequency, ultra high frequency, and the super high frequency. And first, I want to tell you the advantage of the higher frequency. The higher the frequency is, the longer the distance the RFID can transport. And the higher the frequency is, the faster and the more text the reader can read. Furthermore, the advantage of the lower frequency of the RFID. The lower the frequency is, the more information of the tag can store. Second, I want to introduce the application of the RFID. For example, such like access door, access card, iCache, and the ETC, electronic toll collection. Thanks for your listen.
Hello everybody, my name is Wang Dawei. Now I'm going to introduce two RFID experiments. We use a function generator and an oscilloscope and two coils. This, we link the purple coils to oscilloscope and link the upper coils to function generator. First, use function generator to out a signal to upper coils, and upper coils will generate a continuous changing magnetic field. Link this, we put a current on the tube. It will generate current, and a current drive the IC chips. Let the current send back in signal to the reader. Okay, now we put the current on the tube. On the screen is a signal of this current, and you can see there are higher part and lower part. Higher part represent 1, lower part represent 0. There is this current signal. Now I'm going to demonstrate our second experiment. We use a function generator and a tube with a coil. And this is our simulated tag. This is composed of a coil and some capacitor. We link this coil to function generator, and it also can generate a magnetic field. Then we put our simulated tag on the tube. Like experiment 1. The coil will send energy to the purple coils, and you can see the simulated tag will send a signal return to oscilloscope. Thank you.